Back in 2015, the astronomical community reached a major milestone. Until then, Pluto had only ever appeared as a fuzzy blur in our telescopes, even with the Hubble Space Telescope. Its great distance from Earth made it hard to study, and we had no detailed images of its surface. That changed dramatically when NASA's New Horizons spacecraft completed a 9-year journey and flew past the Pluto system. For the first time, we received detailed photographs and scientific data from a world we'd only guessed about. But what exactly did we learn? And what has New Horizons been up to since? Let's start with some basics. Pluto, now classified as a dwarf planet, lies in the Kuiper Belt, an icy region beyond Neptune filled with small, rocky and icy bodies. Despite its demotion from full planetary status, Pluto turned out to be far more fascinating than many had assumed. Initially overlooked, the mission to Pluto only came to life thanks to the persistence of the scientists involved. In 2006, New Horizons launched aboard an Atlas V rocket as part of NASA's New Frontiers program. It became the fastest spacecraft ever launched, speeding past the Moon in just 9 hours, an incredible feat compared to the 3-day journey taken by Apollo missions. Along the way, it used Jupiter's gravity to slingshot itself toward Pluto, reducing the travel time by 3 years. It also used this opportunity to test its instruments and capture valuable images of Jupiter and its moons. 2015, as New Horizons neared Pluto, it began sending back increasingly detailed images. Day by day, the resolution improved, revealing surface features unlike anything previously imagined. The most striking was a large heart-shaped region, now named Sputnik Planitia, a nitrogen ice plain roughly the size of Texas. New Horizons' closest approach was on July 14, 2015, passing just 12,500 kilometers above Pluto's surface. However, we had to wait for the images and data due to both limited bandwidth, about 1 kilobit per second, and the 4.5-hour one-way signal delay. Pluto's surprising surface. What New Horizons revealed was staggering: mountains made of water ice, vast plains, evidence of glacial flows, and signs of atmospheric processes. Sputnik Planitia, a giant nitrogen ice plain with polygonal patterns likely caused by convection. The lack of craters suggests this region is geologically young, perhaps only 10 million years old. Water ice mountains. Some mountain ranges rise several kilometers high, supported by rigid water ice, which acts like rock at Pluto's frigid temperatures. Cryovolcanoes, features like Wright Mons may be evidence of ice volcanoes, suggesting internal geological activity. These may erupt a slurry of water and other materials, resurfacing parts of Pluto. Pluto's atmosphere. One of the most surprising discoveries was Pluto's atmosphere. Though extremely thin, measured in microbars, it extends far above the surface, forming multiple haze layers. Some images captured light filtering through this haze, highlighting Pluto's rugged terrain. The atmospheric composition includes nitrogen, methane, and carbon monoxide, which sublimate and refreeze based on seasonal changes. At times, the pressure might increase enough to allow for transient phases of liquid nitrogen. Some features even resemble frozen lakes, possibly remnants from when the atmosphere was denser. Pluto's moons. Pluto's largest moon, Charon, is especially intriguing. Nearly half the size of Pluto, the two bodies orbit a point in space outside of Pluto itself, a rare example of a binary system. Both are tidally locked, always showing the same face to each other. Charon's surface is mainly composed of water ice and lacks a significant atmosphere. One of its most visible features is a reddish cap at the North Pole, believed to be composed of tholins, organic compounds that may originate from Pluto's escaping atmosphere and settle on Charon due to the two bodies' unique orbital dynamics. Pluto's smaller moons, Styx, Nix, Kerberos, and Hydra, are tiny, irregularly shaped, and likely formed from debris after a massive impact. Tholins and mysterious colors. Dark regions like Cthulhu Macula are covered in these reddish-brown tholins. The distribution of these materials is uneven and still not fully understood. Some may be linked to cryovolcanic eruptions that transport organic materials from beneath Pluto's crust. A possible subsurface ocean. Data from New Horizons suggests Pluto may have once been warm enough to support a subsurface liquid ocean, and possibly still does. Instead of forming as a frozen body, evidence points to Pluto starting off hot. Cracks and expansion features on the surface support this theory, rather than signs of contraction. This raises intriguing questions about habitability, not only on Pluto, but across the Kuiper belt. Arrokoth, a visit to a pristine Kuiper belt object. After the Pluto flyby, New Horizons continued deeper into the Kuiper belt. With the help of the Hubble Space Telescope, scientists identified a small, distant object as the next target, Arrokoth, originally nicknamed Ultima Thule. On January 1, 2019, New Horizons flew just 3,500 kilometers from Arrokoth's surface, marking the most distant object ever explored by a spacecraft at the time, nearly 6.5 billion kilometers from the Sun. Arrokoth appears to be a contact binary, two lobes that gently merged, likely formed from the same cloud of icy debris early in the solar system's history. The surface is reddish due to tholins, and it's largely free of craters, suggesting minimal impacts over time. Its structure, temperature, and surface composition provide a snapshot of the early solar system, preserved in this remote time capsule. Interestingly, Arrokoth is much flatter than expected. Something only discovered after examining New Horizons data over time. The reason remains uncertain but may relate to rotational dynamics or long-term solar heating on one side. What's next for New Horizons? Despite its distance, New Horizons remains active. With fuel left in its tanks and power from its radioisotope generator, it may continue operating into the 2030s. Future plans include turning it into a deep space observatory, conducting astrophysical studies, observing distant planets, and exploring the interstellar medium. Its unique position offers a rare platform for science no other spacecraft can perform. The New Horizons mission has transformed our understanding of the outer solar system. It revealed Pluto as a dynamic world with an atmosphere, geological activity, and potential for subsurface oceans. It showed us Arrokoth, a frozen relic from the birth of the solar system. And it's not done yet. What else lies hidden in the Kuiper belt, waiting to be discovered? Hey, thanks for watching. If you enjoyed this video, don't forget to give it a thumbs up. Share it with your friends, leave a comment down below, I'd love to hear your thoughts, and if you haven't already, hit that subscribe button and turn on notifications so you never miss an upload. Thanks for the support, and I'll see you in the next one.